All right, now let's implement the removeLast method. This is the trickiest part, so pay close attention. We're going to declare a new method, public void removeLast. So let's imagine our list looks like this. 10 pointing to 20, pointing to 30. And we have this last field that is pointing to this node. Now, to remove the last item, we need to find the previous node. This is the tricky part. So we need to traverse this list starting from the beginning. The moment we get here, we need to keep a reference to this node so we can update last and set it to point to the same node. So let's implement this step by step. First, we want to find the previous node. We start by declaring a variable called current, and we set it to the first node. Now, as long as current is not null, we're going to go forward. First, we check to see if current.next equals the last node. If that's the case, we need to break out of this loop. Otherwise, we set current to point to the next node. So at this point, we have the previous node. Now, before going forward, I want to refactor this code and extract this logic into a separate private method, because at a first glance, it might not be clear what we're trying to do here. So let's declare a private method that returns a node object. We can call this getPrevious and give it a node object. So whatever node we give it, it will return the previous node. So let's move this logic over here. Now, instead of working with the last node, you want to work with the node that is passed here. So let's change that. Beautiful. Also, instead of breaking out of this loop, we can simply return the current node. Now, what if we traverse the list all the way to the end, but we couldn't find the node before this node? We should return null. Now that we have all this logic in a single place, we can go back to the removeLast method and call getPrevious, give it the last node, and store the result in a variable called previous. So in this case, previous is going to point to this node. What should we do now? Well, currently last is pointing to this node. We should change last and make it point to previous. So this will shrink our list like this. However, there's still this object that is pointing to this other object. We should remove this link so the garbage collector in Java can also remove this last node from the memory. So we set last to previous. This will shrink our list. And then to remove the link, we set last.next to null. Let's test our code up to this point. So back to the main class. After adding these items, let's remove the last item. Now let's start the debugger. There you go. So here's our list. Let's see what we have here. We have first that is referencing this node. This is referencing this other node. And here we don't have anything after. So we successfully removed the last node. Beautiful. Let's also make sure that this last field is referencing the same node. Beautiful. So we're going to stop the debugger. Now we need to think of the edge cases. What if the list is empty? Just like before, we should throw an exception. So I'm going to remove these comments and check to see if the list is empty. We want to throw a new no such element exception. What if our list has only a single item? This logic is not going to work because there is no node before the last node. We only have a single node. So this logic is assuming that our list has at least two nodes. So we need another if statement. If first equals last, that means we have a single node in this list. In this situation, we should set both these fields to null and then return. So this other logic is not executed. So this is how we implement the removeLast method.